we will be talking about sound absorption coefficient, right, and NRC, noise reduction coefficient, right. We will be also talking about some sound absorbing material, and I have some samples to show you. These are some samples of various sound absorbers which are being used in market, very popular. This is glass wool. Anyway, we will discuss in detail when our lecture ends. So at the end, just remind me, and then we will discussing about these materials and the properties which are mentioned over here in the brochure and catalog. So we will discuss in detail. Just remind me at the end of our lecture, right? So let me share the PPT. Actually, these materials and samples have been collected by your seniors, actually, 4th year architecture, and they did market survey last year, and so many types of materials we have available in our what you call material museum, right? Some of samples are here with me, and I will show you the detailed description which is written over here and what is the meaning of that. We will see each and every detail of material, right, at the end of this lecture. Anyway, let me share the lecture file. Okay, is it visible to all of you, and am I comfortably audible to all of you? Voice clear hai? ठीक है. So in last class we were discussing about sound absorption. I think yes, now it's clear. We talked about the interaction of sound with wall surface or solid wall. So we already discussed about what is reflection, specular reflection if we have plane surface. I will be briefly describing again, and then we will talk about sound absorbing material. Anyway, so this is incident ray, this was specular reflection. If we have rough surface with so much of undulation, we will have this kind of reflection, right, in all direction. Then we can say this is diffusion or scattering, and the bending of sound waves, this is diffraction of sound, right, and we know what is absorption and transmission. Then we talked about echo. We also talked about in detail ki why echo could happen. If the reflected sound is receiving after 0.1 second or 100 millisecond after receiving the direct sound, then definitely echo will be there if reflected sound is strong enough, right? So there were two conditions for echo: the reflected sound and the direct sound. Difference between them should be more than 100 millisecond or 0.1 second. Suppose we are getting direct sound and after 0.1 second we are getting reflected sound. In that case, echo will be happen if the reflected sound is strong enough. Then we also talked about the path difference to control the echo. So we know if we are getting reflected sound after 100 millisecond, there will be an echo, and it is preferable to provide reflected sound within 50 millisecond, 0.05 second. In terms of distance, we also talked about we have 340 meter per second velocity of sound in normal condition. So in that case, it should be less than 17 meter. So this was direct path, this was the source, this was receiver, and this was reflected path, this was reflective panel. So this reflected path and the direct path, difference between reflected path and direct path, it should be less than 17 meter. Then we will receive the reflected sound within 50 millisecond. So we can normally draw the ray diagram whenever you designing or drafting the section of your auditorium or lecture or whatever you are designing. So by simple ray diagram we can find out yes, the reflected path is too much or it is within the desired limit, right? Now obviously we will be talking in detail in chapter number 3 about this typical section and plan of various floor plan for auditorium or library and so many things. So this is the typical layout. If we provide rectangular shape of thing, so this will be reflected sound obviously. Let me mark on this. Yes. Suppose this is direct path, receiver is somewhere here. This is reflected path. Again this is reflected path. But this red one, this is long reflection, right? This reflected path is longer than this one. If this path is too much longer than this one, 17 meter, we discussed already. If this is difference between reflected path and direct path is more than 17 meter, then there will be an echo. So this late reflection we should avoid. So what can we do? Either we can provide kind of sound absorber somewhere here and on the real wall to weaken the reflected ray, reflected sound energy. So either we can provide sound absorbing material somewhere here and here, right? So that this reflected path will get weakened, or we can splay the roof like this. If we reduce the height, or if we try to reduce this reflected path, delayed reflection, then we can achieve the desirable reflected sound. Or we can do some kind of undulation. If this is top floor, so there will not be any issue to make roof like this. Or if this is ground floor or first floor and we have another floor above it, then we can provide kind of false ceiling like that, right, to reduce the delay. So this was kind of solution to avoid echo. We will discuss in detail later on in chapter number 3. Now this is our today's topic, that is sound absorption coefficient, right? Obviously for measurement of any material, how much it is absorptive, we need some unit. So this is measurement of absorption, that is sound absorption coefficient, and this is nothing but ratio of sound energy absorbed to the sound energy incident, obviously in a certain time. Again let me draw something. Suppose this is the sound absorbing material and we want to measure it, what is sound absorption coefficient for this particular material. Suppose this is incident ray, incident sound energy, and this is total sound energy is E0, and obviously some of the sound energy will get absorbed and some of it will be reflected back. So absorbed energy is, we can take EA. Then sound absorption coefficient, generally denoted by alpha, will be equal to EA by E0, right? So this is sound absorption coefficient. This is the ratio of amount of sound energy absorbed to amount of sound energy incident. So obviously value will be in between 0 to 1. And what will be the meaning of 0? If it is 0, that means this is perfectly sound reflective material, very poor sound absorbing material. And if the value is nearby 1, then we can say this is very good sound absorbing material. And if we have value of 1, then we can say this is perfectly sound absorber, right? So this alpha value or sound absorption coefficient vary between 0 to 1, because this is the ratio of energy which is getting absorbed and the energy which is incident on the material, right? Now let's take some examples for sound absorption coefficient. Again it varies from 0. 0 means there is no absorption and 1 means it is perfectly absorbable. So let's take an example of brick wall, 9-inch thick brick wall we have here. This is reflection, this is absorption or transmitted. So suppose we have incident sound energy on this brick wall. 98% of energy is getting reflected back and only 2% is getting absorbed or transmitted. So in that sense we can say the alpha value or sound absorption coefficient will be 2 by 100, that means 0.02, right? If we take the glass fiber 1.5 inch thick, 20% of energy, incident energy, is getting reflected and 80% is getting absorbed or transmitted. In that case we can say 80 by 100, 0.80, and that is very good sound absorbing material. We are having more than 50% of absorption. And in brick wall we are only 2% sound energy is getting absorbed, so we can say sound absorption coefficient is 0.02, right? Now if we take an example of open window, so obviously this is suppose room and we have open window somewhere here and we have sound source here. So obviously the sound which is hitting somewhere like this, it will get transmitted, nothing will get absorbed. So in that sense we can say 100% absorption or transmission is happening, 0% reflection will be here. Obviously if there is no obstacle here, so all of the energy will get transmitted, or we can say absorbed, nothing is getting reflected back. Okay. Then we can say open window, or if you have open door we will have sound absorption coefficient will be 1. Why we are considering open window? When we try to calculate reverberation time or total room absorption, so obviously we will have door and window. So in that case the part surface area having open window or open door, we will take alpha value equals to 1, right? Then we have now we have a clear understanding of what is sound absorption coefficient, mostly denoted by alpha, and value varies from 0 to 1. If we are near by 0, then very poor absorption. If we are getting value near by 1, then we can say that is very good sound absorber. Okay. Now this is average value of sound absorption coefficient, or normally we can say sound absorption coefficient. What is happening here? Suppose we have sound absorber. For that we are trying to find out what is sound absorption coefficient. The sound energy is hitting to the surface at the normal to the surface actually. Okay, perfectly normal. Second case we can say sound energy is hitting like this. So obviously absorption will be little bit different in this case and this case. So we are getting alpha 1 if we are normal incident ray. If we are getting like this, so we can say this is alpha 2, and we will take in all direction, right, random direction. Incident sound energy is hitting towards the surface, and we will have different value of alpha 1, alpha 2, and then we will take average of that. The sound ray are hitting with different direction. We took alpha value for different sound incident energy, and we will divide by this. So this will be average absorption coefficient, because whenever we use sound absorbing panel inside the room, obviously sound energy will be coming from all direction, right? So we will take the alpha average value of sound absorption coefficient. And if we see, it depends on material also. Some material having very good sound absorption coefficient, maybe this alpha value for normal alpha n will be equal to alpha average, right? So we will not get into detail. We will take the average value of sound absorption coefficient, right? Because if we are designing library or auditorium and we are using sound absorbing panel, so obviously sound energy will be hitting from any angle, from different angle, right? So this is average sound absorption coefficient. Now again the description of same thing by different way. Now these are various materials and we have different value of sound absorption coefficient. Let's take an example for glass. If we have glass, ordinary glass, sound absorption coefficient is 0.1 to 0.2. That means only 10 to 20% of sound energy is getting absorbed and 80 to 90% is getting reflected back. So we can say this is sound reflective material. In case of plastered wall, 0.01 to 0.03, that means 97% to 99% is getting reflected back. Again this is reflective material, right? If we take timber board, again this is reflective material because value is nearby 0. In case of curtain, 25 to 35 is getting absorbed and 65 to 75 is getting absorbed. So we can say this is sound absorbing material, because if we compare with plastered wall or concrete wall, this is far better than concrete wall in terms of sound absorption, right? If you take mineral wool, it is absorbing 65%, polyurethane foam 95% of energy is getting out. This is very good sound absorber, right? So we will see various materials and their sound absorption coefficient, right? So these were some examples. Now take examples for sound absorber. We can have porous absorber, we can have cavity resonator, we can have reflection panel. So let's see, discuss one by one. So this is porous absorber, right? You can see these pictures. So these are very efficient at high frequency, and these are not very good for low frequency. Suppose you are using 25 or 50 mm thick porous absorber, so this will perform very good in case of higher frequency and middle frequency range also, but low frequency it will not perform better. For performing better in case of low frequency, you need to provide little bit more thick porous absorber, or you can provide by providing some air gap between the wall and this porous. We will see. Suppose this is kind of panel having porous absorber, and this is the wall, brick wall or something, and we can provide air gap. Then this will be acting good for low frequency. Otherwise, this is very good for high frequency and middle frequency, right? So these are perforated or textured material. These are available as acoustic board or acoustic hanger, right, or geoacoustic tile also. We will see various kind of fixing detail also. We can hang normally on ceiling also if we have very less area and we need to provide more and more sound absorber. We can provide acoustic board, we can hang on the wall, or we can fix it, simply paste it. We have other variant also, the acoustic plaster or sprayed fibers material, blanket, carpet, so many things. So these are examples for porous absorber. Due to porosity, sound energy get absorbed. Frictional loss will be happen, right? Now this is again very important thing. We talked about sound absorption coefficient, how much energy is getting absorbed, right? But we didn't talk about the frequency. Now if we look carefully, we know hearing range, our hearing range is 20 Hz to 20,000 Hz, 20 kilohertz, right? This is the hearing range of human being. And if we see speech range, if you remember, 125 Hz to somewhere 8,000 Hz. Check it once. I think this is okay. 125 Hz to 4,000 or 8,000 Hz, right? This is speech range of human being, and this is hearing range, 20 Hz to 20 Hz. Now let's try to look at the rough concrete and the sound absorption coefficient. So if you see, for 125 Hz frequency of sound, we have 0.02, that is sound absorption coefficient. That means only 2% is getting absorbed, 98% is getting reflected back. But in case of 4000 Hz for higher frequency, we have 0.07, that means 7% is getting absorbed and 93% is getting reflected back. That means we will have different sound absorption coefficients. Properties of sound absorption will be different for different frequencies, right? So we need to take care of these frequencies also. Once again, I think somebody is trying to join. Okay, I think I have PDF file also for various materials and their sound absorption coefficient. Yes, this is here. Let me zoom a little bit. Is it visible, this PDF file? Please respond, anyone? Visible है? ठीक है. Okay, so try to look at, firstly we will see the material which is used for masonry wall, right? So let's see rough concrete, right? So this is, again let me mark or something. Okay, blue color is okay. This is blue. Yes. At 125 Hertz we have 0.02, this is sound absorption coefficient, and for higher frequency it is 0.04. So we can say in every frequency this will act as sound reflective material, that is not sound absorber. Like in case of plastered wall, again we have 0.04, again sound reflective material, and for a higher frequency also we have 0.06, that is again sound reflective material. Let's take example for glass. If we have 6 mm glass, sound absorption coefficient is 0.10, then that is again sound reflective material, and for higher frequency is again acting as sound reflective material, right? Let's take wood paneling with air gap. Let's take this 12 mm plywood and with 150 mm air gap, right? Change का air gap रखते हैं. In that case, for lower frequency, you can see the sound absorption coefficient is almost 0.3. That means 30% is getting absorbed. So this is better than the previous one, the concrete wall. But for higher frequency, again we have property is kind of sound reflective material, 0.09. But for lower frequency, absorption is more. If we are providing air gap and plywood, between plywood and wall, we have air gap, right? Again, let's see some examples, other examples. Yes, glass wool, that is again very good sound absorber. And let's take example for 25 mm. Suppose we are taking glass wool of 25 mm, about 1 inch, and this is the density of glass wool. For lower frequency, it is not performing well. This is again kind of reflective material. But for higher frequency, if you see at 4000 Hertz, this is very good sound absorber. 74% energy is getting absorbed. Sound absorption coefficient is 0.74 for higher frequency. So for higher frequency, this is good. But for lower frequency, this is not performing very well, right? And if we are increasing the thickness of glass wool, for lower frequency also this is performing better than the previous one, and for higher frequency almost 100% of energy is getting absorbed, because sound absorption coefficient is 1, right? So these are various material. We can change the assemblage of various material, and we can see the sound absorption coefficient. So that will be useful while you designing your any built-in moment that is very sensitive to sound. Then you can choose according to your requirement, right? I will mail this PDF file, and I will mail lecture file also, don't worry. So these are various sound absorber and various material having sound absorption coefficient, right? Again, audience and sitting, that's also very much important. Suppose you are designing a cinema hall for 1000 people, so you need to consider the person who are sitting. For 1000 person, if you are designing, the per person, we discussed in last class also, we can say the person or the sitting is also will act as a sound absorber. If that is textured sofa you are providing, or any kind of textured surface with sitting, so you can see if person sitting, 33% for lower frequency, sound absorption coefficient is for higher frequency 0.45. So you can see say that is absorb this sound. And obviously, suppose you have designed for 1000 person and hall is empty, or maybe only 10% is filled by the people and 90% chairs are not occupied. In that case, the reverberation time or environment of sound will be different. So we need to take care of that also, because every time it was not houseful, it will not be houseful, right? So we will see what we can do in that case. So various sitting with leather cover, that is again better sound absorptive material, right? Then water surface, water is again very kind of sound reflective material, right? Almost all of the energy, sound energy will get reflected back, right? So these were various materials with their sound absorption coefficient, right? This I will talk later on. This is again very important. Whenever you purchase any kind of sound absorbing panel or sound absorbing material, on the brochure or catalog you will find NRC, that is noise reduction coefficient. And again, noise reduction coefficient NRC is nothing but average of alpha value, average of sound absorption coefficient at 250 Hz, 500 Hz, 1000 Hz and 2000 Hz. We have seen the particular sound absorber were performing differently at different frequency, right? The alpha value was different for different frequency. So we will take alpha value for 250 Hz, then 500 Hz, 1000 Hz and 2000 Hz, and then we do average, arithmetic average, that means divided by 4. So that will be NRC. So you can say NRC is the average of sound absorption coefficient at 250 Hz, 500 Hz, 1000 Hz and 2000 Hz. And then we will round it off of 0.05. Suppose we are getting 0.59 or maybe 49, so we can write 0.5. It will be multiple like this, 0.6 we can write, or 5.4, so we can write 5.5 like this. So this is the NRC. Again, yes, this is the simple formula. Noise reduction coefficient is average of alpha at 250 Hz, 500, 1000 and 2000, and then average of that. So that is noise reduction coefficient. So because we are considering only absorption at 4 frequency, so again obviously this will not give very accurate property of that particular material. But yes, this will give a rough idea what is that material and how is the sound absorbing property of that material, right? And we know our speech range vary from 125 Hz to 8000 Hz, right? And we are taking only from 250, at 250, 500, 1000 and 2000. We are not considering 4000, 8000 Hz. We are not considering alpha value at 125 Hz. So obviously if you are designing library or maybe auditorium, and we will the sound from 125 Hz to 8000 Hz also, so in that case this NRC value will not give the accurate information. So if you are designing very precisely or very important space which is sensitive to sound, then NRC will be not enough informative kind of thing. You need to know alpha value at different frequency, how much it will absorb at different frequency, right? But you are designing, suppose corridor, you are treating the corridor, then you can use simply NRC. With good NRC material we can use accordingly. But you are designing auditorium or library or like that, you need to know the alpha value for different frequencies. What is the properties for lower frequency and what is the properties for middle and high frequency of that material we are going to use, right? So this was about NRC, noise reduction coefficient. This is the average value of alpha. And again, NRC is not, as the name suggests, the difference in sound level between two conditions or between two rooms, because this term says noise reduction coefficient. Suppose we are taking room, we have adjacent room, this is common wall, and we have sound source. Suppose TV or living area is somewhere here, and this is study room. So obviously sound will be transmitted through this wall, and in that case we can say noise reduction is this much. But NRC is not this kind of thing. NRC is simply average of sound absorption coefficient. We will have different terminology for that. This is transmission loss. We will discuss later on, maybe in chapter 3 or 4. So we have clear understanding of sound absorption coefficient, alpha value, that is different for different frequencies for same material. We know the same material can be could be used as sound reflector for lower frequency, and same material will perform as a sound absorber for higher frequency. It may happen. So we need to take care of that. And NRC, noise reduction coefficient, is average of 4 alpha value, sound absorption value at 250 Hz, 500, 1000 and 2000 Hz, an average of that. Again the same thing, NRC. You will be finding NRC, simply written NRC on the brochure of material. I will show you various material and their product description which is written on the brochure. And this is the average of alpha value. Yes, these are various pictures I have taken from our material museum. And your seniors actually collected all these materials, samples. They did market survey last year. I think your third year architecture batch, right? Now they are in fourth year. And obviously this year it doesn't seem possible to do market survey. But whenever you get time, try to visit market and try to find these materials. So this is kind of porous absorber. This is in blue color. We can have different color also according to requirement. And if we see the product description, you can find the thickness of, that is 9 mm, the dimensioning, panel is 8 feet by 4 feet, and we have density 230 or 240 kg per meter cube. And now we have NRC, noise reduction coefficient. This is 0.85. So that is quite good, but this is not giving clear information about this is good for lower frequency or this will act as an absorber, good absorber at higher frequency. This is not clear. So we need to know. If you are designing musical room, you know we will have lower frequency also, or HVAC or fan is there. So obviously the sound which is coming out from HVAC or fan, mostly low frequency sound it is. Or mostly it is difficult to deal with low frequency sound. We will see what can we do. So this was about product description. Again we have this wood kind of texture, this kind of texture. This will scatter the sound and as well as absorb the sound, cork type. Again this is, I think, glass wool. This is, yes, again this is glass fiber wool, and this should be covered always, right? Because this fiber material is very fine and it could be inhaled, and this will be dangerous for respiratory system, or irritation in eye may happen. So this should be covered. You must have seen this kind of glass wool, and this is always covered with panel. You must have seen the timber panel like this, and behind it and between the wall, if this is panel and this is wall, in between we can use glass wool. So it should be covered always, right? This can be also sound absorber. Sometimes we use the hot water pipe or AC ducts. It should be covered by sound absorbing material. And mostly sound absorber or sound absorbing material is also good thermal insulator. Not all the case, but most of the time. We will discuss in detail. Suppose you have this kind of material and you have porosity. So if this porous things are connected to each other, and we have porosity on the surface also, so this will act as good sound absorber and good thermal insulator also. But suppose you have porosity like this is not interconnected, so this will be maybe a good good thermal insulator, but it will not acting as sound absorber. Anyway, we are talking about sound absorbing material. So glass wool or rock wool is again very good sound absorber, and you can find the thickness and these kind of thing, product and density and all. Let me zoom this. Actually picture is not very clear, but tell me if it is it clear, visible?
Yes sir. Yes sir.
So this is NRC having 0.85, that is good sound absorbing material. This is kind of textured material, you can see the red color, and we have detailed description of that for different frequency. What is sound absorption coefficient? For 125 Hz you can see 0.08. So that means only 8% of energy is getting absorbed. So that is not acting as a sound absorber for lower frequency. But if we see for higher frequency, 1000 Hz, 2000 Hz or 4000 Hz, we are having even more than one. Sound absorption coefficient is 1.04 or 0.86. So for higher frequency this is performing very well, but for lower frequency 125 Hz or 250 Hz, this is not performing very well as a sound absorber, right? So we need to know these kind of thing, detailed description of that material. We can have various colors also, and the panel, kind of panel, how beveled edge or square edge we have. The sizes is given 600 by 600, 2 feet by 2 feet, and thickness is 25 mm. So these materials you can see in market or in our material museum also. So many materials are we collected last year, and these are the sample one, right? This is not 600 mm. Now we can have panel absorber also. You can see the picture, right? These are the panel absorber, and there is some air gap between the ceiling and this panel absorber, right? This is the plywood panel. Behind it we can provide some kind of sound absorbing material, glass wool or something, any fiber material, and this is the wall. This is again gypsum board, and you can see this is small porosity, small holes we have, right? These are the. So due to this will be acting as a sound absorber. And if you see in detail, look, noise reduction coefficient, that is 0.55, lightweight and easy to install. These are some kind of square we can have, or this kind of reveal, or this kind of various type of jointing, edge with various edges. Now if you see, these are the dimension, 2 feet by 2 feet, 15 mm thick only. Color white, different color we can have. Light reflectance 82%, more than 80. Light reflectance is also very important phenomena. Suppose you are designing library and you are dealing with ceiling, wall and floor also. In case of ceiling, you can go up to 90%. By the way, light reflectance is again very simple term. 82% means 82% of light will get reflected back of incident light, right? 82% will get reflected back. So that means it will be kind of bright when light fall on this. So in case of library, the ceiling having less than 90% of light reflectance. For wall, it should be less than 50% light reflectance, or for floor or tabletop, you can say it should be 30%. You can see IS code for light reflectance also. That is again very much important phenomena, because when you read book, the background you may have flooring or wall, so light reflectance value should be limited. Glare is also a different phenomena. You must have studied your illumination subject. I think last semester you had building services. Anyway, we can have RH value also, that is up to 95% humidity resistance. Thermal conductivity, again you must have studied in your climatology or whatever. So thermal conductivity is also very good, 0.057. As we talked about, most of the material having very good thermal conductivity. Actually thermal resistivity should be good, and very good sound absorber also. So you can find different properties. Acoustic value NRC that we are talking about right now, 0.55, and very lightweight it is, 4 kg per meter cube, 4 meter square actually, right? So try to understand this detailed product description, and you have visited also, you have some samples, so try to get the information and try to understand what are terminology which is mentioned on this process. Again, we have gypsum board and various fixing details has been given, and so many things, right? If I zoom, I think picture is not very clear, but let's try to see. Physical data, NRC, CAC again very important. We will see what is CAC when we design partition wall and all, or ceiling also. And again so many things has been provided. RH, right? I think picture is not very clear. Anyway, now this picture I have taken from the software, I think Odeon software. Actually I have taken from another faculty's lecture. Rajasekar, he is currently serving as an assistant professor, I think, at IIT Roorkee. So I have taken from his lecture slides. But anyway, you can find so many softwares are also available, very nice software, and this will give very accurate information about the panels. So let's see any one sample of that one. You can see the panel, we can choose slot absorber, perforated facing, or slat absorber, or we can have plain. So you can choose the various type of material, and by default so many materials are provided in these things. So here what we have done, Let me do the full screen. Yes. 1 second. Let me check. Yes. We have plywood panel chosen here. We can choose the density. Here it is 8.4 kg per meter square. This is concrete wall, right? And in between the wall and the panel, we have provided glass wool, and the thickness is 25 mm. To try to see what is the performance of this particular assemblage of material, we have plywood, concrete wall, and in between wall and plywood we have 25 mm thick glass wool, right? Now this graph shows how it is performing. This is frequency of sound. We have 63, 125 Hz up to 6000 Hz, and this is sound absorption coefficient, right? So you can see for this particular frequency, maybe around 70 or 75 to 120. This is kind of good absorber. We are getting up to 0.7 and very sharp edge we are getting. But for higher frequency, it is not acting very well when we have chosen the plain simple plywood and glass wool, right? So let's take another example. In second case, we have increased this thickness. Rest of things are same. We have concrete wall, this is plywood, density is again same, but we have increased the gap between plywood and concrete wall, and now we have 50 mm thick glass wool, right? So let's try to understand what we are getting. In previous one, graph was like this, and now we are getting again very sharp absorption, but for lower frequency we are getting almost 1.3 the sound absorption coefficient, right? So this is again very sharp. We are only for, this is very useful for maybe 100 to 120 Hz frequency. This will act as very good sound absorber, but for higher frequency we are getting nothing. This is perfectly reflective material. So let's take another example. We can have slat absorber also. Again these are plywood panels, but we can provide some gap between the panel. So here it is 25 mm of gap between these two panels, and width of each panel is 100 mm, and we can provide some gap between the panel. Again we have gap between concrete wall and the panel, that is again 25 mm, and then see, this is the graph. In previous case it was like this, the graph is shifted towards right. Now this will cater maybe from 150 Hz to 4000 Hz as a sound absorber, almost 0.8, right? So when we provide slat absorber by providing some gap, we can change the gap and you can see the various property of that material. So this software is very nice, and this is glass. So this is behavior of sound absorbing properties. So for higher frequency and middle frequency, this is performing better when we provide this kind of assemblage. Another assembly, let's see, we can have perforated facing, right? These small holes. I think this picture would be clear to you. Gap between these holes is 9 mm, and again the dia of this perforation, this hole, is also very important. Here it is 3 mm, right? And the distance between these two porosity, two holes, is 9 mm. Again we have provided glass wool behind the panel, in between the concrete wall and the panel. You can see the graph. It was like this when we had slat absorber. Now for perforated facing we are getting better than the previous one. So now again this is covering from 125 Hz to maybe 5000 Hz. So this is sound absorption coefficient almost 1. So for middle frequency and higher frequency, this is very good sound absorber. So we can change this dimension, change the gap, we can change the material, we can change the thickness and all that. You can play in different way. So try to install any one software and do practice it, and it will be useful. Maybe next semester you have thesis, and maybe your design is a little bit more towards the sound. If you are somebody is taking auditorium and all, then this software will be very useful. We will try to see, if time permits, the description of this software maybe at the end of our lecture, right? And I think this is the last slide for today. We have type of space. Suppose for private office or large office, or maybe we can have a small conference room, this is the preferred NRC range. This will be okay if we take in between 0.65 to 0.75 NRC range. If we are treating fully the ceiling treatment, and then wall treatment will not be required in case of small conference room and large office. Even our conference room having the ceiling treatment, you must have seen, and it is fully treated, and the NRC range you can take. So this is kind of thumb rule, and wall treatment is not required. But if you are designing corridor, so obviously corridor have the wall or gap between the wall will be not much as small conference room, maybe 10 feet or 12 feet or like that. So in that case we can treat the seal fully and wall treatment will be required. In case of gymnasium, because of high volume, we need to treat more. We will see in detail these kind of layout, how to deal with it. So in that case you can take NRC range in between something, and wall treatment will be required and ceiling treatment. So this is kind of thumb rule, right? So I think that was enough for today, but before ending I will show you some materials that we have.